just have to make a quick... Unfortunately, he realized that he couldn't quite do justice to the man himself, and then he was a bit stumped, but he's been out searching all of the farmyards around in Connecticut for any sheep herders that may be able to handle Newtonian better even than Carl. I think Carl would be the best, but unfortunately we're going to have to make do with a number 2.
Oh my.
Found the sheep.
Corpus omne perseverare in statu suo quisciende vel movendi uniformiter indirectum nisi quaternos illud a viribus impressis cogitur statum suum mutare. Every body perseveres in its state of rest or of uniform motion in a right line, unless it is compelled to change that state by forces impressed thereon. Mutationem motus proportionalem esse vi motrici impressae et fieri secundum lineam rectam qua viscera imprimitur. The alteration of motion is ever proportional to the motive force impressed, and is made in the direction of the right line in which that force is impressed. Does everybody understand? Is everybody here ready to learn the secrets of the universe?
No, we're here to hear about you, Dr. Newton.
Excuse me? To hear about me?
We're here to hear about your life.
I was told to come and talk about the universe. But you would rather listen or hear about me?
Yes.
I do not understand, but I would rather read from the Principia Mathematica. But if you must have your way, and I don't know why you want to know about me, on the secrets of the universe, far more interesting. A picture of me. What is this thing? I press a button. Very well. If you want to hear about me, my name is Isaac Newton, Professore Lucasianus, Mathematic, Universitae Cantabrigiensis. Lucasian Professor, the University of Cambridge. This seems to be my family tree. I was born on Christmas Day in 1642. It was 2 o'clock in the morning. Christmas Day, 1642. The same year that Galileo died. My father was also called Isaac Newton. I never knew him. He died in October of that year, having married my mother in April of that year. So I was born on Christmas Day. They feared that I would die. Perhaps I was premature. I was so small, they claimed they could fit me in a quart pot. My head kept flopping over. They had to equip me with a bolster. Everybody was convinced I was going to die. But I lived. I lived another 85 years. But back to Christmas Day. I was baptized on the 1st of January, 1 week later. I was baptized in Colsterworth Church. What are these buttons? There is my home, the manor house in Woolsthorpe, Lincolnshire. Lincolnshire is a county in England. You see my bedroom? This is my bedroom. And this was the room in which I was born. For those of you who are not widely travelled, this is a map of England. And I was born and raised somewhere here. Grantham is where I went to school. The manor house in Woolsthorpe is somewhere here. I would later go to university at Cambridge, down here. That's about as far as I travelled in my life. But I also travelled to London. I did once advise somebody about travelling abroad, but I never travelled abroad. This is a map that I'm more familiar with. Here is the manor house of Woolsthorpe. Here's Suiston, a few miles away, where my mother, Hannah Ayscough, was from. Grantham, where I went to King Edward VI School. Cambridge is far down there. Burton Coggles. Burton Coggles is somewhere around here. That's where my uncle, William Ayscough, was rector. Here's a more modern photograph, picture of the Woolsthorpe Manor. Notice the tree. I spent many a happy hour during my Annus Mirabilis, 1665 to 1667, sitting by that tree. There is my front room. Notice the quart jugs. They tried to fit me in that. There's the bed in which I was born. It was a difficult birth. It was difficult times. War was raging in England. The troops, the parliamentary troops, marched past my house to north in pursuit of Charles I. He got his just deserts a few years later when he lost his head. I was not aware of the troops, of the turmoil. I was just, because I was a sickly baby. I was baptized in Colsterworth Church, just a couple of miles down the road. My childhood was a lonely childhood, filled with torment, as was my life. My first crisis came when I was just 3 years old. My mother, Hannah Ayscough, did I mention that my ancestors were all illiterate? My father, my grandfather, my great-grandfather, they were yeomen, they were lords of the manor. None of them could even sign their name. My mother, Hannah Ayscough from Suiston, she was almost illiterate as well. Her brother, William Ayscough, did graduate from Cambridge University, so he claimed to be somewhat clever. My childhood was troubled, though. At the age of 3, my mother abandoned me. She went 1.5 miles down the road to marry Barnabas Smith, a bloated heathen. Barnabas Smith, the rector of North Witham, 1.5 miles away. When I climbed to the top of the tree, I could even see the spire of the church, but I was not to see them very much. My mother left me in Woolsthorpe Manor with my grandmother, while Barnabas, who was already 60 years old, fornicated with my mother and reared and produced 3 more children before he died 7 years later. I confess I hated Barnabas. He didn't want to know me. He never allowed me to visit. He wanted his own progeny, I suppose. I rarely went to North Witham. But he died, and fortunately he did bequeath me something. He left me 300 books, 300 theological books. Perhaps that is where I developed an interest in theology. And he left me one book in particular. It was a commonplace notebook. He wrote on the first few pages some titles, some theological titles that he intended to get to eventually, and on every page he wrote a title. But he never wrote anything. He was not a very productive person. He was rich. He was very wealthy. It was obviously a marriage of convenience. He did leave my mother a lot of money. The manor house was worth £30 a year income before my mother married Barnabas. When he died, he bequeathed her lands in the will that brought another £50. He also had a private fortune of £500. So it was a good marriage in one sense, but a hateful marriage in another sense. He didn't even have the manliness to propose to my mother. He sent one of his lackeys to talk to my mother's brother and say, would Hannah marry me, do you think? What a bloated fool. Anyway, the commonplace notebook, I called it the waste book for obvious reasons, except in that I wrote, there germinated the first ideas of the fluxional calculus, the theory of fluxions, and the interpretation of Descartes' work, and the expansion of Descartes' work, and the theory of the heavens. This is an important book, so the historians say. When I was barely 12, my mother returned home, and we were together for a couple of years. I had spent my childhood whiling away the hours, thinking about this thing and that thing, occasionally making toys. Sundials. I loved to make sundials. I would put sundials on the outside of the manor house. I would watch the motion of the sun and the motion of the heavens. And this is what amused me. But Hannah returned when I was with her for 2 years, until at the age of 13, 12 or 13, I had to go to grammar school to learn things. I'd gone to local schools, and I'd learned rhetoric and logic, but then I went to grammar school in Grantham, a few miles away. This is King Edward. Oh, I recognize the school. King Edward VI School in Grantham. And in Grantham, I lived with Apothecary Clark. Apothecary Clark. He was you would call him a chemist, a pharmacist. He dabbled with potions. Perhaps I got my interest in alchemy from Apothecary Clark. But I lodged with him. And also lodging with us were his 3 stepchildren, Arthur and Edward Storer, and Ms. Storer, whose first name I forget, except I liked her. I didn't get on well with boys. I preferred the company of girls. I'm not sure why. But Miss Storer and I developed quite an affection for each other. I made her dolls' houses and toys. I also made a windmill. They were building a windmill near Grantham. And I looked at the windmill and I thought, I can make a windmill. And I made a toy windmill. And I put a mouse in the windmill, and that caused the wheel to turn. And I tweaked the tail of the mouse, or maybe I just fed him the corn that was ground and so on. And it worked. This is how I spent my childhood, making toys and endearing myself to girls, in particular Miss Storer. We developed a romance, but it wasn't to be that we were to marry. In order to marry her, I would have to take the vows to be ordained, to be a cleric, like Barnabas. And I couldn't afford to do that. Or rather, I didn't want to be a clergyman. I wanted to be a scholar. So it was not to be. Although I always remained friends with Miss Storer, who later became Mrs. Vincent. And in her old age, I helped her out at times. She was always a friend, but that was all. So I was lodging with Apothecary Clark. I was whiling away my time making windmills and dolls' furniture and kites. Kites were fun. I make a kite and I would look at the motion of the kite through the fluid medium, the ether, and it would fly better than anybody else's kite. And I would make lanterns with candles in them to light my way to school. And occasionally I'd put the candle and the lantern on the kite and fly it over the neighborhood. And that would scare people because they thought the comets were coming to the apocalypse. Of course, while I was doing this, I wasn't studying very much. I was bottom of the class, and I remained bottom of the class. At King Edward VI School, I studied Latin and Greek and some Hebrew. Very little mathematics. And my mind was not on my studies, which means I was bottom of the class until something profound happened to me. One day, one of the Storer brothers, I think it was Arthur that I was lodging with, we got into a fight, and he kicked me in the belly, and I snapped, and I beat him. I fought him, and the boys at the school egged me on, and I fought him, and I drew blood. And maybe, what do I have here? Oh, pictures of my school. I'll tell you about Arthur again in a moment. Here's my schoolhouse. Oh, there's a window in the schoolhouse. Anyway, Arthur kicked me in the belly. I fought him. I beat him. And I rubbed his nose against the wall. And I determined that, okay, I had bested him physically. Now I would best him intellectually. I didn't know anything, but I was inspired. I was inspired to best him. And so I began to rise to the top of the class. And as I rose to the top of the class, I carved my name. I left my legacy. I carved my name. Isaac Newton on the benches. And also I carved my name on a windowsill. And that windowsill still exists in your time. There's my writing, Isaac Newton. I carved my name on the windowsill in King Edward VI School in Grantham. Oh, a sundial. I made this sundial. How old was I? 9 years old? A sundial. I was following the heavens. There's the wall that I rubbed his nose against. Wonderful. I rose to the top of the class. About this time, I bought a notebook as well. And I became aware of a book by a man called Bate. And it had models, pictures of things in it, and lots of geometric shapes. And I scrawled these shapes all over the walls of Apothecary Clark's house as I drilled and knocked holes in the wall. You can imagine Apothecary Clark was not very happy with me. And in this notebook, I copied things from this book. And oh, look, this is interesting, isn't it? There are cures here for various ailments. This is a cure for an obstruction of the spleen. And how do we cure that? Oh, yes, you take some horse dung and you ferment it with ale. And you let it settle for days on end. And then you drain it and you drink it. And it cures the ailment. And another cure I read about for a fistula was it involved millipedes. You take 400 millipedes, was it, and you tear their heads off, and you put it in ale, and you stir it up, and you imbibe it. It cures all sorts of ailments. The stoppage of urine and wind, oh yes, that was a good cure. I think the ale helped as well. I get ahead of myself. This is Trinity College, Cambridge. So I'm at school in Grantham, and I'm rising to the top of the class, but unfortunately my time was done, and at about the age of 17 I had to return to the manor house, because I was meant to be Lord of the Manor. This was my destiny, to be Lord of the Manor. Hannah wanted me home to do my chores, to do my job, to satisfy my legacy, and it was impossible. For the next 9 months, life was impossible. When I went to the market with one of the servants, I would bribe the servant to go to the market while I would run off to Apothecary Clark's house and study the alchemy books. Or at another time, I would bribe the helper to go to the market while I stayed on the roadside with a book. And when he was coming home in the evening, I would join in and I'd be back at home. And when I did stay at home on those rare days, I was meant to tend the sheep, but the sheep wandered to everybody else's land because I was so obsessed with my toy making and my windmills and my water mills and so on, and my studying. And the sheep wandered, and my mother got fined, and it was impossible. So what was to be done with me? Well, my thanks be to God for my uncle, William Ayscough. He convinced my mother perhaps Isaac is better suited to things of the mind. And a friend of the family, Mr. Humphrey Babington, also, who graduated from Cambridge. He was the brother of Apothecary Clark's wife. He tried to convince my mother to let me go back to school. And what did it, I think, was that Mr. Stokes, the headmaster of the school in Grantham, said, yes, he should come back to school. Not only with that, but I will pay his tuition. Not only that, but I will let him stay with me in my house, because Apothecary Clark didn't want me back. I'd already defaced all of his walls. So I was back at school, and then, happy of course, my thoughts went to the heavens. I rose to the top of the class again, and on those days when I slipped down, I would read a book and I'd pull myself up again, so on. And I was ready for Cambridge. And in the year of our Lord, 1661 it was, in June, I went to Trinity College, Cambridge. A month later, I matriculated at the University of Cambridge. I was now a student at the university, but a subsizar. My mother was rich. She could afford to pay my tuition, but she didn't want to afford more than £10 a year. So I went as basically a slave to the other students, or to the dons, to the fellows of the college. I would put their hair in order in the morning. I would help dress them. I would empty their chamber pots of their piss. And this was how I was able to stay at the university. Trinity College, Cambridge, founded by Henry VIII. There he is. Henry VIII. Ah, the great quad at Trinity. What fond memories. There was my lodgings. There. I lived near the Porter's Lodge. And not far from there, in future days, I built myself a little workshop to do all my alchemy. I bought a furnace and did my alchemy. So I'm at Trinity College, Cambridge, being a subsizar, reading Aristotle and Plato, no mathematics, Greek, the Bible, of course. I'd already studied that in Grantham. I studied again at Cambridge. And in 1662, after a year at Cambridge, I had a crisis. My next crisis in my tormented life. And I wrote up a list of sins. I think there were 55 sins that I committed in my life. And this is in shorthand due to Mr. Shelton. Samuel Pepys wrote his diary with the same shorthand, presumably to hide things from you. And in particular, number 13, you read it. This is shorthand. It says, I fantasized about burning their house down around them, referring to my mother and the porky Barnabas Smith. But there were many other sins. Taking thy name in vain, spitting water on the Sabbath, being peevish, calling Auntie Betty a cur. Lots of sins. It was a crisis. I was Puritan. I was pure of mind and pure of spirit. My goal in life was to study the heavens and to learn the ultimate truth, the meaning of God. I'd renounced vices of the flesh. So my sins. At the same time as an undergraduate at Cambridge, I bought another notebook. These notebooks are available today if you look hard for them. And I titled this, can you read it? Plato Amicus, or rather Amicus Plato, Amicus Aristotle, Magis Amica, the truth. I'm a friend of Aristotle, I'm a friend of Plato, but I'm a bigger friend of the truth. And I labeled this is the first page in my notebook, Questiones Quaedam Philosophia. And there were 45 headings, for example, of the first matter. And another one, of God. My goal in life was to understand God. God that ruled the heavens and God that ruled the smallest atoms. This was my only goal in life. Because as you can see, God, if be no God? Why would our parts, our atoms not arrange themselves in some chaotic order? And you would have 3 eyes instead of 2 eyes and 5 arms instead of 2 arms. There has to be a God, an eternal creator who is with us all the time to keep the heavens moving. So I thought about God. I thought about atomes. I thought about motion. I thought about gravity and levity. I thought about violent motion, collisions of particles. We're all aware, I trust, of Descartes and his vortex theories. How else could the moon move around the earth or the planets move around the sun unless the ether is filled with vortices, great swirling matters that collide with each other and push the heavens around? I studied this. Of light. Of light. We will have more on this in a minute. Of light. At that time, I was ignorant enough to believe in the possibility of perpetual motion. Gravity waves passing through the ether, like a flux, a fluvium. Perhaps we could use these gravity waves to turn veins perpetually. And magnetic waves, why not? Why cannot we have perpetual motion with a magnet pushing something around? These are the things I thought about when I was an undergraduate at Trinity College, Cambridge. Of sounds, I was interested in sound. I was not a musician, alas, but that doesn't mean I can't think about sound. Pythagoras' rhythms, the rhythms of the universe. I was convinced that the future inverse square law of gravity was somewhere in Pythagoras' music of the spheres. We've all heard, I know, of Kepler's music of the spheres. I was interested in sound. I came up with a 12-point scale for sound, the octave divided into 12 pieces. Of sleep and dreams. These were the things I worried about, fragments of incoherent dreams. Where did it come from? Was it from God? Of vision. Vision. While I was an undergraduate, I did experiments in light. And one experiment consisted, oh yes, that was it. I would stare at the sun for hours at a time. Because then I noticed that when I closed my eyes and opened it at other points, I would see images of things, fantasies. And I would stare at the sun again, and it almost blinded me. For about a month once, 4 weeks, I could not see anything. But it was a good experiment. And another experiment, one that I loved a lot. This is my eyeball. What I took was I took a bodkin, a long spiky instrument. Oh, here's a spiky instrument. And I pushed it at the back of my eye. And I pushed really hard. And I squeezed on the other side. And I noticed colors appear. Rings of color. And I pushed even harder. It did not do my eyes much good. But I learned things. I could produce colors. What is this thing anyway? Ooh. Lux Rosa. Ah. There. Ah, this is a useful instrument. The bodkin and my eyeball. And, well, enough on that. This was a parchment that I wrote many years later in my old age. It was addressed to a Huguenot by the name of Des Maizières. He had asked me, he wanted to write an elegy to me after I'd become famous, and I obliged him, and I always wrote things many times, many drafts, because if it's only when you write something many times that you can be sure that it gets better. The first draft, no good. The 10th draft, possibly good. And this was one of the drafts that didn't get to him. And it describes what happened in 2 years of 1665 to 1666 to 1667. Why did I? Well, it was during those years that I returned home to Woolsthorpe. Why did I return home to Woolsthorpe? Does anybody know why I had to leave the university to go back to Woolsthorpe? because of the plague. The Great Plague had descended on London and it had found itself to Cambridge. And late in the year of 1665, the students were sent home and I went back to the manor house. I did return to the university the following March 1666, but just for a few months because the plague reared its venomous head again, and I returned home again to the manor house till 1667. And I'm recalling the things that I did in the manor house at that time while I was at home trying to be a student. I had already got my Bachelor of Arts degree. I'd been at the university for 4 years. But then the plague descended and I went home, and I thought I had wonderful years too. Annus Mirabilis. And this, can you read this? Can you read it? What does it say? It says in the same year, in the beginning of the year 1665, I found the method of approximating series. You call it the binomial theorem, I think. Reducing any dignity, approximating series, the rule for reducing any dignity, binomial. Okay, the same year in May, I found the method of tangents. At the university, although I'd studied no math, I'd been mentored by Isaac Barrow, the first Lucasian Professor, and he had shown me a book by Descartes. He'd shown me a book about Euclid as well, Euclid's theorems. In fact, Barrow had written this book. And I studied Euclid and I found it self-evident. And then I studied Descartes, and that was not so easy. I would struggle. I would read a few pages, and then I would be stuck. So what did I do? Did I go to Mr. Barrow? No. I would go back to the beginning and work harder. And I'd cover a few more pages, and then I'd go back. And eventually I mastered Descartes' work on geometry. And during my Annus Mirabilis in Woolsthorpe, I developed the method of tangents, an extension of something that Descartes had started. And I had the theory, the method of fluxions, all in 1665, I think it was, perhaps 1666. My memory is frail. I'm an old man now. And then the following year, I discovered colour. I'd already worked with prisms and played with my eyes, but I had a theory of colour. I wanted to know the truth of God's firmament, so I studied colour. I came up with a theory of colour. And later on in the year, perhaps it was 1666, late in the year, I came up with the method of inverse fluxions, the method of quadratures. You call it the integral calculus, I think. And all this during my 2 years. Oh, there was something else. I was aware of the great works of Kepler. He was the person that said that planets went around the sun in ellipses. And it is a high school problem to determine from Kepler's laws that the force of attraction between two bodies might go like the inverse square of the distance separating their centers. And I looked at the moon. I recall, yes, an apple. I was near the tree one day, meditating on the heavens, and an apple fell to the ground. And I seem to remember thinking, though my memory is frail, that the apple fell vertically. And what if it fell from a very high tree? What if it fell from the heavens? What if it fell from where the moon was? Perhaps what caused the apple to fall to the ground, perhaps that explains why the moon is falling towards the earth. It is falling, you know. Why is it falling? Galileo had shown that a natural motion is motion in a straight line. The moon is moving in a circle. It is falling away from a straight line. It is falling towards the earth. It's not getting any closer, but it's still falling. It has an acceleration. And I thought about this, and this was all in these 2 years, and the inverse square law, and I knew that 1 degree of latitude represented 60 miles, and I knew that the moon was 60 times an Earth radius away from the Earth, and I did a calculation, and the moon's acceleration agreed pretty closely with my calculation, but not exactly. So perhaps the inverse square law was wrong. Perhaps Descartes was right after all. Perhaps there were vortices causing the motion, as well as an inverse square law of attraction. All this I did in these 2 years because I was in the prime of my youth. This is an interesting way of imagining how the moon's motion can be related to the projectile motion of things flying through the air. If you take an apple and throw it, It moves along a parabola. Descartes knew about parabolae, and I knew more about parabolae. I studied his work and I extended everything he did. This while I was barely an undergraduate. And imagine the projectile to be thrown further and further. It falls to the ground, but eventually it might not hit the ground. It will move in a circle. Isn't that like the moon? This appeared later on in my opus magnum, the Principia Mathematica. There is a picture of Isaac Barrow, the first Lucasian professor, my mentor at Cambridge. Descartes, a clever fellow, but I extended everything he did. This is a manuscript. This is one of my jottings that I wrote while I was at Woolsthorpe. You can't see much of this, I don't think. I wrote very small. Paper was very precious. Thanks be to Barnabas Smith for leaving me his waste book. I covered the pages in my doodles, my calculations. Does anybody see a little pendulum there? I don't think so. Here, this manuscript consists of the calculations of the acceleration due to gravity. I looked at the works of Galileo, and I mention Galileo here, and I mention other things here. Basically, I'm thinking about what keeps the moon going around the Earth. December 1664. I occasionally dated my work. I don't know why. Probably to keep track of everything that I was doing. And what do we have there? Having found the former rule and equation in which the quantity of crookedness, the curvature of a line, in any line may be found to find the greatest and least crookedness of that line. This is the calculus, the germ of the theory of fluxions and inverse fluxions, and the secrets of understanding the universe. To resolve motions, to resolve problems involving motions, 1666. It's all to do with the planetary motions. Here, another more scribblings of mine in my attempt to understand the motion of the moon around the Earth. It's a pity the inverse square law didn't seem to work. I would discover much later on that the inverse square law worked admirably. I had the answer in my grasp. If only the people that determined the distance of 1 degree of latitude had got the number right. It's not 60 miles, it's 69 miles. If you put that into my scribblings, perfection. I had explained the motion of the moon around the Earth. And in one fell swoop, although it took many years to appreciate it, it was an extended fell swoop. I universalized gravity. The same theory that described the motion of the moon described the motion of an apple near the ground. And why not describe the motion of the Earth about the sun? The planets about the sun. This is what I'm famous for, the universalization of gravity. God is omnipresent. It is his law that is universal. The inverse square law, it's simple. There, my work in music, 12 points to an octave. And at the top of this, I see some number theory. And over there, what do I see? Nautical questions. Of course, I was interested in latitude. In the future, I would be interested in how to help ships know where they were at sea. That would involve the invention of a chronometer. But that was beyond me at this time. This is the first page on the waste book, Barnabas Smith's book. Notice his scribblings is in Greek. And below I start writing profound things. You see a little pendulum, a conical pendulum. More scribblings. My calculations got very complicated. Do your calculations get complicated? Do they go on for many pages? Yes. This is the beginning of one calculation. Antichristus. This was one of the titles in the waste book. Well, I found better use for this precious paper. A telescope, or the beginnings of a telescope. And more scribblings. You see the pendulum again. You've all heard of Christian Huygens. He was on the continent, one of the Continentals. I had a run-in with him later in my life. And when I was not musing on the heavens and heavenly motions, I would calculate things. This is to 55 decimal places. I've heard that somebody invented a calculating machine which enabled you to do this very quickly and very accurately. I only had my brain and my patience. There is a hyperbola. I'm finding the area under a hyperbola. The inverse fluxional calculus is the integral calculus. And this is my evaluation of the logarithm of 1 plus 0.1 to 55 decimal places. It passed the time. And I was interested in optics. This is all while I was at Woolsthorpe for those 2 plague years. I had mastered Descartes' geometry, and I was very good with my hands. Ask all the little girls that I built toys for. I was good with my hands, and so I was able to grind my own lenses using Descartesian geometry principles. More lenses. I wasn't much of an artist. And I discovered at something like 1665 a prism. And I played with the prism, and I did many experiments with the prism. And using the prism, I noticed that if you let sunlight shine on the prism, what do you get on the far wall? You get an oblong of colors. This inspired me. It excited me. Somehow, I had proven in one simple experiment that light is made up of a heterogeneous mixture of colors. I called them red, orange, yellow, green, blue, indigo, violet. There were many colors in between, but I thought 7 is enough. These are just some of my scribblings in optics. More scribblings, a very simple experiment for you to do. Take a thread, color one end of it red and another end blue, and look at it through the prism. And what you will see is that the 2 ends of the thread are disconnected. Why? Because different colors are refracted through different angles. Refraction, refrangibility as I called it. The experimentum crucis. A prism. I was at home in Woolsthorpe, and I poked a hole in the shutter and let a light beam through. And the light beam was on a prism. And I got an oblong of color. And then I intercepted one of the colors with another prism. And it too was refracted, that color. But it didn't change the color. This excited me. I wrote on it. What did I write on it? Nec variam lux fracticolorum. Nor does refraction change the color. But I was unsure of myself. I wrote it and I scribbled it out. I wrote it and I scribbled it out. And then I wrote it, and thanks be to God, I believed it. And because of my work in optics and my discovery of refraction, and my problems with refraction was that it split the light into colors, I discovered that a telescope, a refracting telescope, will not work well, because you'll see lots of colors when you don't want to see colors. But I knew enough to say that if I put a mirror in there and reflect the light, that doesn't split the light. It's a reflecting telescope, a catadioptical telescope, and I made it. In fact, I did not invent that. Although the Royal Society would attribute the invention to me, I always gave credit to the people who invented things first. And I sent this telescope, which was only 6 inches long but could magnify things 30 times. I sent it to the Royal Society along with an improved sketch for the telescope. And this was in December of '71 that I notified the Royal Society in London about my telescope and my musings. And immediately there was turmoil in London because of this brilliant discovery, which wasn't really a discovery. And they made me fellow of the Royal Society. And I was inspired. For the first time in my life, I was inspired to let somebody else know the secrets of my work. I had written many treatises, several treatises on mathematics, the universal arithmetic, the analyse, and so on. But I had disdain for confrontation, so I never published anything until the Royal Society inspired me to let them know that I had a theory of colours. And they were interested in that. I sent it to them in February of '72. And why did I send it? It was a brilliant piece of work. It was based on 7 years of my work, from my days in Woolsthorpe through to 1672. It was perfect. It was God-given. And what happened? Well, confrontation. Robert Hooke, who you must have heard of, that disdainful fellow, immediately said, no, I had this theory before. Or, I don't agree with your corpuscular theory. Light is but a pulse through the ether. And there was Christian Huygens on the continent who said, you only need 2 colours, not 7. And there was Reverend Pardis who said that the reason I got an oblong of colour was because I had a finite circle of white light on the prism. And I responded to these people. I was patient. But there was no satisfying them, so I flew into a temper and I said, I'm withdrawing from natural philosophy. But many years later on, in 1704, all my work in optics would be gathered together in a masterpiece, Opticae. It was published in 1704. I think this is the original manuscript. It looks very old to me. Beautiful pictures. Notice, I explained the rainbow, the primary bow, the secondary bow. Descartes had sort of understood that, but I understood it better. My work with prisms and multiple prisms, prisms upon prisms. I was good with my hands. And then, meanwhile, Cambridge University had discovered that I was bright. And in fact, I was already the Lucasian Professor, because in 1669, a few years before all this furor was let loose, when I let the Royal Society know about my existence, in 1669, Isaac Barrow, the first Professore Lucasianus, he aspired to higher office. He wanted to be the King's Chaplain, and he became the King's Chaplain. He wanted to be the Master of Trinity College. He became the Master of Trinity College in the future. He had to resign his professorship, though. Who was to fill the chair? Me? I was a precocious youth of 27. He nominated me for the Lucasian Professorship. You have a gentleman by the name of Stephanus Hawking. He occupies my chair. I was the second Lucasian Professor, the most prestigious position in mathematics in the world. Stephen Hawking is supposedly quite a bright fellow. But in 1675, I nearly lost it all, because I encountered another crisis, a theological crisis. I acquired a first degree, my bachelor's degree. I'd become a Master of Arts. Each time I had sworn to the Holy Trinity. I had to swear the oath of the Holy Trinity. In 1675, I would have to swear it again to retain my fellowship. But in the meantime, I had made a terrible discovery. I'd become interested in theology. And I went to original sources. I wrote over 1 million words in theology, you know. Do people know that I did something other than the calculus? That I spent years studying atoms in alchemy, breathing mercury vapor, using barrels of urine to do my chemical studies? Not very healthy life. But I also wrote many words in theology. I went to the ancients, and I discovered a terrible thing. There was a gathering of fellows in the Convention of Nicaea in 323 AD. There was Arianus and there was Athanasius. And Athanasius had promulgated the idea of God the Father, God the Son, and God the Holy Ghost. Arianus believed in an almighty God, and that Jesus was a divine, but not of the same substance as God. And all the literature before then, the biblical studies, revealed that Arianus was right. But in cahoots with the Pope and the Holy Roman Emperor, Athanasius had won. But I knew the truth. There was only one God who inhabited the universe and who began the universe and kept the planets moving. But Jesus was just a divine, immortal person. And I knew the truth, and I could not swear to the Holy Trinity again. I could not be hypocritical. It would be the ultimate sin. What was to be done? I would have to lose my position as Lucasian Professor. Fortune shone on me. King Charles II, in April of 1675, granted the Lucasian Professorship dispensation from taking to holy orders. I was saved. Thanks be to the eternal God. And the years passed, and I pursued my theology and my alchemy, my little furnace outside Trinity College. I would spend days and days sleeping. No time for sleep. How many hours do you work per day? 10 hours? 11 hours? Right? What's wrong with 24 hours? Occasionally you have to sleep. There is no time for pleasure. Playing games is time wasted if you want to understand the ultimate truth. And the years went by. I studied my theology, I studied my alchemy, and I was repulsed by Robert Hooke and the likes of him that had dared to challenge my theories. But in 1679, Robert Hooke contacted me again, and he posed a problem, and he said, if something falls near the surface of the earth, and imagine the earth is in two hemispheres, and the something can move inside the superficies of the earth, what would be the trajectory? And I wrote back to him, and this is his letter. He's asking me what would be the trajectory. And he suggested, and I wrote back, and I said, first it will fall east of where it started, and then it will continue to fall, and it would spiral into the center of the earth. Oh my God, what a mistake! What a mistake. Of course, it's not true. It's a slip of the pen, of course. But he interpreted it as a mistake, and he jumped on it. He wrote back immediately within a week saying, Noble Newton, I'm afraid you're wrong. This hurt me. He said it's a form of ellipse. It rancored me. Why did I communicate with these people? But then I caught him. I wrote straight back to him. And I said, you're wrong, Hooke. It's a trifoliate. Because I understood it. So I won that battle. And the years went by. And then, in August of 84, I'm 42 years old now, am I? In August of 1684, this time travel is difficult on my... In August of 1684, Edmund Halley, you know of Edmund Halley? Halley's Comet. He visited this lonely scholar in Cambridge, Isaac Newton, and he posed a question. It was a question that he tried to answer with Robert Hooke and Christopher Wren in the coffee houses in London. And the question was, what is the trajectory of a planet about the sun under an inverse square law of attraction? And I immediately said, it's an ellipse. I knew about an ellipse. And he was amazed. I don't know why he was amazed. They had tried to prove it, that an elliptical orbit implied an inverse square law, as well as an inverse square law implying an elliptical orbit. I knew this. I'd done it 7 years before. He was amazed. And he said, have you done any more work in the dynamics of the heavens? And I said, yes, I delivered lectures at Cambridge, both in optics, and as Lucasian Professor, I had to deliver a lecture once a week for 45 minutes and keep 2 hours of office hours. Not that anybody ever came to my office hours. Few people even came to my lectures. And I'd given a lecture course on De Motu Corporum. And I gave Edmund Halley a short manuscript. And he took it back to the Royal Society, and it caused another stir. a huge stir. And he contacted me again and he said, will you expand on this and write a treatise on dynamics? And I agreed because Edmund Halley was a jovial, nice fellow, one of my few friends in the world. And during the years 1684 to 1686, 2 years, I spent my time with the help of an assistant, an amanuensis by the name of Humphrey Newton, not related. I spent those 2 years conceiving of the contents of a great book. Yes, many years before I thought about motions and I'd done my doodles, but in those 2 years I created the content from the mind of what would be the Principia Mathematica, the mathematical principles of natural philosophy. Law 1 and law 2 and law 3, to every action there is an equal and opposite reaction. These to me were sensible laws, but there was more to it. And in those 2 intense years I wrote many hundreds of pages of manuscript, and my amanuensis transcribed it, and Edmund Halley took it and arranged for its publication. And the Royal Society unfortunately could not afford to publish it. So Edmund Halley said, I will pay for it. Thanks be to God for Edmund Halley. Also, when I was writing in the 3rd book of the Principia Mathematica, Philosophia Naturalis Principia Mathematica, Robert Hooke emerged from the woodwork like the slimy worm he was again and said, I want credit for the inverse square law, because I had discovered it before. I refused. Edmund Halley said, please, just give him a footnote. I refused. I said, withdraw the 3rd book, The Motions of the Heavens. I don't want anything to do with it. But he was a diplomat as well. He mediated between me and Robert Hooke, convinced Robert Hooke to let me write it without acknowledging him. And so, because of Edmund Halley and nobody else, the book came to light, the Principia Mathematica. And I became famous. And I became tired of Cambridge. At the end of the century, I became famous. I was even elected to Parliament for a couple of years in the 1690s. Let the records show that I once asked somebody to open the window. It's in the parliamentary record. And I became tired of Cambridge. I became tired of controversy, of confrontation, of people claiming that I'd made hypotheses when I didn't ever make hypotheses. Everything I did was the truth. It was based on experiment, not the idle musings. I didn't even theorize on what caused action at a distance between the moon and the earth. Cartesian vortices, okay. I had to invoke the first cause, the God of the heavens, the omnipresent God. But I didn't try to explain God. The second cause, the mechanical ideas, they worked as well, but I never claimed a theory of action at a distance. I was tired of Cambridge, though, and I was looking for employment in London because that's where the action was, the Royal Society. What was happening in Reformation, Restoration Cambridge? Nothing. Professors showing up to class and nobody showing up to listen to them? Nothing. The action at a distance was in London, the Royal Society. And so I wanted to be there, and I asked Lord Halifax, can you pull a few strings for me and get me a job in London? And the jobs weren't easy to get, even for the Lucasian Professor, who had published the brilliant opus magnum of the Principia Mathematica, which none of you will be able to read. But Lord Halifax found me a job, Warden of the Mint, because there was a reformation in the currency at the very end of the century. And they thought, why not make me the Warden of the Mint in charge of the currency of England? And I accepted the job in 1696. And a few years later, I became Master of the Mint, in charge of the currency of England, producing much currency. I was on a commission as well. I got very rich. And I was a brilliant administrator. And I sent many a cur to the hangman's noose. The person I'm thinking of is Challoner. I watched him hang. I administered some of the trials of these people, let them counterfeit my currency at their peril. And in 1705, I was knighted by Queen Anne. And I became president of the Royal Society, this body of men that was so noble and so knowledgeable. And I showed you the optics. It wasn't published until after Hooke died. Although I'd started the publication before he died. Let history not represent that as an act of vengeance. The publication had started, but it appeared after he died. Let historians say what they will about that. I was president of the Royal Society. Here are pictures of my workers at the Mint, grinding away the coins day after day, 24-hour shifts. I was in charge of it all. And the years passed. And apart from the priority dispute with Leibniz, which will be a story for another time. No, it's a story for this time. Leibniz, I think Leibniz plagiarized my fluxions, my theory of fluxions. Let the record show, the epistolum, the acta epistolum, I think it was. Let the record show that Leibniz was a plagiarist. Many people would claim that he invented it independently. Of course, I had invented it years before. I just hadn't chosen to publish it. I will say no more about that priority dispute. Let Leibniz be gone. And I passed the days as Master of the Mint and President of the Royal Society, and it worked very efficiently, I might say. I was a very good administrator. And I'd given up mathematics many years before, but there was one instance. Soon after I arrived in London, my niece, Catherine Barton, was living with me, a beautiful woman. Jonathan Swift wrote a poem to her. Voltaire fell in love with her. But she kept my house. And she received one day a letter from the Bernoullis, the continental scientists. And the letter posed two questions, two problems, one of which was the following. If you have a body falling in a gravitational field from one point to another point, what is the path joining those 2 points such that the time it takes is a minimum? You might say a straight line. You'd be wrong. Think. You've got to think. Spend 20 hours a day thinking, and you will not say such nonsense. It was a difficult problem. And the Bernoullis, and probably Leibniz, and some other continental genii, they had worked on it for months and months. Catherine gave me the letter when I got home from the Mint one day, tired, exhausted. And I put my mind to it, and I stayed up, and at 4 o'clock in the morning I had the solution. There were two problems. I had the solution to both. In future days, the solution to the one problem, the brachistochrone problem, would be called the calculus of variations. I invented it in a few hours. It was brighter than the Bernoulli brothers. And the years passed, and eventually I began to get ill. And in 1727, as March 20th approached, I was very ill. I had the stone. I passed a stone at one point. That's very painful. But I got a lung infection. That was very painful. Supposedly the room shook as I groaned. And on March the 20th, 1727, I succumbed at the tender age of 85. It was announced, the London Gazette, published by authority. It announced my death and I lay in state in the Jerusalem chamber of Westminster Abbey for about 4 days. And then my body was committed to the ground in Westminster Abbey in London. I was buried alongside the kings and queens of England. And my glory. And all said and done, what did I achieve? Did I discover the ultimate truth? Did I discover God? Perhaps I had some insight. I don't know what men will think of me. But to me, it's almost like I was a boy on the seashore, finding a smoother pebble or a prettier seashell, while the whole ocean of truth lay before me. I've spent too long here. I need to get back to my musings on mathematics, natural philosophy, theology, alchemy, and I'll run the currency of England in my spare time. Thank you for being patient. Go back to your studies now.